Moving on to proof by induction for the formula of a geometric series. We have to prove that Sn is equal to A, open bracket, 1 minus r to the n, all over 1 minus r. Now, by this stage, we've already seen a couple of videos on, 3 videos on proof by induction, and we know it's absolutely essential that each time we do proof by induction, we follow these 4 very, very important steps. Step 1, need to show it's true for n equals 1. Step 2, assume it's true for n equals k. Step 3, need to show it's true for n equals k plus 1. But we must use step 2 in so doing. And as we saw in the inequality proofs, we must also possibly use step 1 as well. And at the very end, no matter how far we get in step 3, we must finish off our proof by saying, step 4, proof follows by induction. Now, what's the problem with Sn? We forget what Sn is. Sn is the sum of the first n terms. Sn is equal to T1 plus T2 plus ... Tn. And because people forget that, they can't even start the problem. But what is T1? Well, T1 is equal to A. This is a geometric sequence. What is T2? It's AR. What is T3? It's AR squared. And what is Tn? Tn is this term here. So let's actually zoom in to make it clearer. So don't forget, whenever you see something like Sn, Sn is T1 plus T2 plus T3 plus ... plus Tn. So if you do not write that at the top, you will not be able to start the problem. So now we're in the position to actually definitively state this proof properly. And we're now going to state we need to prove by induction, not Sn is equal to the right-hand side, but what Sn is. And Sn is A plus AR squared plus so on, AR to the power of n minus 1 is equal to this. And what we now see is this is a sequences and series proof, which is back to the very first video. So we need to show it's true for n equals 1. So when we're doing n equals 1 for step 1, it means the left-hand side is equal purely to A. So we can now write down here, left-hand side is equal to A. What's the right-hand side equal to? Well, back to form. We write out what the formula states. It says 1 minus r to the power of n. Now, you don't have to put the power of n in there if you don't want. You could save yourselves a line of working out by simply putting in the value for n straight away. And the value for n, of course, is 1. So now we've got a 1 minus r on the top. We've got a 1 minus r on the bottom. It's a show that question. So you can use pencil to cancel out the 1 minus r on top and the 1 minus r on the bottom. And then you can go straight to the final line, which just says the right-hand side is also equal to A, therefore shown true for step 1. Because this is a sequences and series proof, when we move on to, or series proof, when we move on to step 2, we are going to be replacing the n with a value of k. So we've now got step 2, assume true for n equals k. Therefore, what have we got? We've got the statement A plus AR, we only need 2 terms, plus ... plus A to the power, A on R to the power k minus 1 is equal to a on 1 minus r to the power of k all over 1 minus r is assumed true. Okay, so we've got maybe 7 marks out of the 15 at this stage. In a bad year, i.e. lots of students getting it wrong, they might even give you 10. Step 3. Well, step 3 is very clear. Step 3 says you've now got to show this is true. You've now got to show this is true for n equals k plus 1. Now I'm just going to move this up to generate just a little bit more space. So we've got to show it's true for n equals k plus 1. Now, what we said when we did series before is that because it's a up to n equals k plus 1, this at the moment is up to where n equals k. So we have to write out exactly what's written here. And because we're going to one term more, then all we've got to do is add the extra term on at the end. So essentially what we're doing, at the moment, we have got in step 2 sk, and sk is t1 plus t2 plus ... plus term k. We are now going to be doing sk plus 1, which is term 1 plus term 2 plus ... plus term k, and then plus the next term, the k plus 1 term. And that's why when we're actually expressing step 3 algebraically, we must write those down first. So we're down to the therefore need to show that A plus AR plus ... plus AR to the k minus 1. That's up to the kth term, but we want k plus 1. So we're now going to replace the n with a k plus 1. So if we replace the n with a k plus 1 and then take off 1, then we're going to end up with AR to the power of k. Now we could have also spotted that from the fact that each time you go an extra term, the power goes up 1. There's lots of different ways of doing it. So that's the left-hand side tidied up. What's the right-hand side going to be? Well, n only features in one place on the right-hand side. So we're going to replace the n now with k plus 1. So therefore we've got a open bracket 1 minus r, and the n is being replaced by the power k plus 1 close bracket all over 1 minus r. Need to show that this expression, we can just put the word this in, put the word true at the end. But we have to use step 2 in order to show it. So let's go to the proof bit. So the proof bit, to play it safe, I am going to write out the left-hand side as it's currently written. I do not cut corners on this. I don't advise any student either. So, and what I've just finished writing is step 2. And to make it into step 3, that's the extra term. So this is when the highlighter pen comes out. So I'm highlighting up here what step 2 actually says. And what step 2 actually says is that this thing here, up to the k minus 1, can be replaced by this, because we're assuming that the left-hand side up here is equal to this right-hand side. So I come down here and I highlight very carefully what am I replacing. I'm replacing the step 2 part, and I'm replacing the step 2 part by a on 1 minus r to the power of k, close bracket, over 1 minus r, plus a r to the k. And what am I trying to get it equal to? I'm trying to get it equal to a on 1 minus r to the power of k plus 1 all over 1 minus r. Okay, why have I done that? Why have I written the right-hand side? Because I'm going to be ticking it, looking at it, thinking about it, in order to make my problem slightly easier. I could take a chance now. I could actually do my working out all on this line. But there's a danger with that. The examiner might not see this line clearly. There might be marks for this line, and you are cutting corners. You could lose marks. What's the way around it? Use a different colour. So in the exam, you're advised that you can use black or blue. So that's what I'm going to do. Pay attention. What am I looking at now on the right-hand side? I am looking at, on the right-hand side, what do I need? I need an A out in front of a bracket. That's called factorisation, which means I have to factorise on the left-hand side an A. Am I in a position to do that? Well, let's take a look. Do I have an A in both terms? Yes, I do. So if I want, I could factorise that now. Well, let's do that. If we do that now, at least we're showing that we're getting some method marks. So I'm taking out A as a common factor. So I've now got left 1 minus r to the power of k over 1 minus r. I've taken a out as a common factor, so I've got r to the power of k. So I've moved it on 2 lines. Surely I've got method marks now. So if I go to the end and write down proof follows by induction and don't do anything else, well, yeah, I've probably got most of the 15 marks. Okay, let's keep going. I've done the A bit. It's done. Why did I write the right-hand side again on that? Because I'm using it as a palette. I'm using it as a way of checking off my mathematics to help me move forward. Memorising this sort of proof is not an option. Understanding, using tricks, thinking is the way forward. So what is the other common factor which has been isolated? And people don't recognise this very often, but this is a single item on the bottom, which means it's being factorised out. So, do I have a 1 minus r on the bottom of the first term? Yes, I do. Do I have a 1 minus... Well, it's a bit of a rhetorical question that. Of course I don't have a 1 minus r on the bottom of the second fraction. But I need it. I surely need it. So, tip x comes out, and I'm going to put a 1 minus r on the bottom. What have I done? I'm putting a division symbol in. So I've put in a divide by 1 minus r. How do I undo a divide of 1 minus r? I do a multiply by 1 minus r. So now I've moved it on. Can I now factorise out the 1 minus r? Yes, I can. So I can factorise out the 1 minus r. So I'm going to bring it out and I'm going to put it underneath the a without any loss of generality. So now I've got 1 minus r to the power of k. And I do feel like at this stage I should be cutting a few corners. So the 2 greens have come out. So all I've got to do now is r to the power of k times 1. Well, that's not difficult. Now, if you prefer, I won't skip lines today. I could just do that little handy working out line. Don't do the expansion of the brackets, and I can do that on the next line. I've got no problem with that at all. I just need to generate a bit of space for myself. So, on the next line, I've now got A over 1 minus R, open bracket, 1 minus R to, I think I've made a slight mistake. So I'm just going to have to go back and just correct my mistake. I do apologize. So what I had here was I took out the 1 minus R and I was left on top with the 1 minus R to the power of K. Then I forgot to write the plus sign. I've taken out the 1 minus R, so what am I left with? R to the K on 1 minus R close bracket. Okay, so that's now done. So what I'm going to do now is I'm going to finish this problem off. Now, in order to finish this problem off, I do need to just generate just a little bit more space for myself, because I do want you all to see this on the one page. Okay then, the last bit. I've got equals A over 1 minus R, open bracket, 1 minus R to the K, plus R to the K on 1 is R to the K, a plus on a minus is a minus, and now we're going to employ the laws of indices. R to the K on R to the 1 is the multiplication of bases, and when we multiply two items with the same base, we add the powers. So R to the power of K plus 1. Because we've done that, it now means that the minus RK and the plus RK cancel out. And if you look, we've now got 1 minus R to the power of K plus 1, which is absolutely identical to the right-hand side. So I'll just do a little neat tidying up line. So I've got A, open bracket, 1 minus R to the power of K plus 1, close bracket, all over. And now I'm going to slide that 1 minus R back into the middle again. I can clearly see that that is identical to the right-hand side. So I can now say it's identical to the right-hand side, and therefore my proof follows by induction. Step 4, my proof follows by induction. And that's it. Clearly there's no questions on this because they'd just be required to actually do this proof. So therefore, in order to practice this, you have to go to pencil and paper. You have to work through it yourselves. Don't memorize it. Please don't memorize it. You need to go back and see if you can get used to the prompts. Because if they give you a series question, which isn't this, which they can legitimately in the exam, you've never seen before, then you have to use the techniques, not memory. So in proof, it's technique, not memory, that counts. Good luck.